friends, in this video we will try to solve problem on population genetics. So a small population of 10 flowering plants is given, and that is conducted as an experiment to examine the change in allele frequencies over 3 generations. So the plants were grown in identical conditions in a controlled environment. Within the flowering plants, the presence of capital M allele allows purple flowers to be produced, while white flowers can only be produced when small m genotypes is present, means totally recessive condition. So here the table shows all 3 possible genotypes. One is totally homozygous dominant, second one is heterozygous, as well as third one is totally homozygous recessive. And genotype numbers in first, second and third generation is given. So we can see that for small m genotypes, only two flowers, means white color flowers, are present in the first generation, whereas in the second generation 4 flowers are there, and in the third generation 6 flowers are there. So we have to find out the reason for this population of flowering plants having more small mm genotypes and white flowered phenotypes after 3 generations. So we have to find out due to which process this happens, that in the first generation homozygous recessive genotype having white flower only we get 2 plants, whereas in the second generation we get 4 plants, and in the third generation we get 6 plants. So there is an increase from first to third generation. So due to which process this happens, that we have to find out among the answer options. The options are: option A suggests that is happened due to genetic drift, option B suggests this is happened due to natural selection, option C and D says that this is happened due to divergent and convergent evolutions. So one thing please note down that according to theory, evolution is a long-term process. After a long time, means many of the generations, there should be drastic change in particular phenotypes of particular parental generation or else into their offsprings. So here only 3 generations are given. So divergent and convergent evolutions, option C and D, is directly excluded, whereas in natural selection there should be any driven force must be present, like due to some reasons mutation happens, due to some environmental conditions like stress and any other natural disasters, this is happen, and due to this reason we get this increasing ratio of a particular genotype. But here in the problem they didn't mention any of the driven force. So again, natural selection can't be a right answer. Whereas genetic drift we all know that it's a random event, means due to some reasons particular one genotype, number of particular alleles, or else we can say that particular one genotypes is drastically reducing. So this reduction in number of particular genotypes in first generation due to this random events or random mating into this intra-species interactions. In the second generations, the number of this particular genotype that is selected is higher than first generation, and if the third generation happen, then in the third generation the ratio numbers are higher than the second generation, and so on. So yes, in the table it is given that number of small m genotype, means totally recessive alleles, is increasing in that fashion, means 2 numbers are present of white flowers in the first generation, whereas in second numbers it is becoming 4, and in the third generation it is 6. So this is due to the random event chance for any reason small m genotype number is very much decrease in the first generation, whereas in the second generation it is increasing, and in the third generation and so on it is increasing in ascending order. So yes, for such kind of a problem genetic drift is the right answer. So if my videos are helpful to you, please subscribe to my channel. Thank you. Have a nice day.